Today's lesson is more quadratics, and this form is going to be factored form. Last class, we talked about standard form, ax squared plus bx plus c, and we looked at all the different ways to use it to graph our parabolas. Today, we're going to look at what we call factored form. And it is of the form f of x equals a times the quantity x minus p times the quantity x minus q. And that is where our factors are going to come from. Our roots, our zeros, our solutions, and our x-intercepts are going to be p and q. But first, let's slow down a little bit and just talk about the stuff we already know. If a is greater than 0, just like last time, it opens up. If a is less than 0, if it's negative, it opens down. The parabola does. If the parabola opens up, it has a minimum. If it opens down, it has a maximum. Nothing new so far. Now the vertex is the max or minimum point on the graph. The x value of the ordered pair is x equals p plus q divided by 2. Interesting. And the y value can be found by substituting the x into the equation. Now, I'm going to show you a different way that I think is much easier than using this format. But it's going to be up to you, to what you feel comfortable with. The domain, again, is the set of all x's, and it's always negative infinity to infinity. The range is the set of all y values, and again, if it goes up, it's y to infinity, and if it goes down, it's negative infinity to y. Always, 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 and these are brackets on the y. The axis of symmetry is the line that passes through the vertex of a parabola that divides it into two equal halves. Now the equation here is x equals p plus q divided by 2. So it's a little different than standard form. However, I don't use that formula, and I'll show you why here in a second. Now the roots are obviously where the parabola intersects the x-axis. The other names for that are x-intercepts, solutions, and zeros. And it just so happens that's p and q in this form. Those are the factors, or the zeros, the solutions, the roots, the zeros. The x-intercepts are p and q. So let's go through this and see if we can narrow this down a little bit, narrow our focus into what all this actually means. Well, the first thing I would suggest you do is to fill out what we know. Now I'm going to write this equation down here again. A x minus p times the quantity x minus q. So what's a on number 1? Negative 3. What's p? 4. What's q? Now I know a lot of you will say 2, but it's not. It's negative 2. Because the x plus 2, this is minus q. So therefore, the sign on q must be negative to make a positive. Now that is all we need to make this happen. Okay? We know it opens down. Why? Because a is less than 0. It's negative. We know then that it has a max because of that. We can now go, we can put in the domain because it's always the same. We can now go down to the intercepts. They are 4 and negative 2. Isn't that nice? So we have two solutions. 4 and negative 2. Okay, now, the formula to find x is p plus q divided by 2, which is 4 plus negative 2 divided by 2. 4 minus 2 is 2. 2 divided by 2 is 1. So that's pretty easy to use the formula. So x is 1. So I'm going to draw in our axis of symmetry, because that is x equal 1. And that's also the first part of my vertex. But I want to show you another thing. Notice that the distance from those points halfway is if we count 3 over to the left and 3 over to the right. Do you see that that is x equal 1? So you can do this visually, and that's the way I do it. I just count. I don't use this formula very often, so it's totally up to you. If you want to use p plus q divided by 2, go for it. Okay? Now remember, to find y, we have to substitute x into the equation. So the equation is going to be kind of ugly, but that's why we have calculators. So you put 1 into the original equation, so negative 3 times 1 minus 4 times 1 plus 3. So that's negative 3 times negative 3 times 4. Oh my goodness. That's going to be negative 36. So our y value is somewhere way down here, right? Way down there. I think I did the problem right. P plus Q. 4 minus 2 is 2. 2 divided by 2 is 1. 1 minus 4 is negative 3. 1 plus 2, sorry. It's not negative 36. It's not going to make any difference. Still a big number. Negative 27. Positive 27, sorry. Positive 27. Negative times negative. So it's going to be way up here somewhere, 27. I apologize. So our parabola then is going to look something like this, all right? So our vertex is 127. So our max value is 27. Way up here, 127. And then our range is negative infinity to 27. Now, I got to check and make sure I did this right. 4 and negative 2. 4 plus negative 2 is 2. 2 over 2 is 1. So 1 minus 4 is negative 3. 1 plus 2 is 3. Negative 3 times negative 3 times 3 is positive 27. So that's correct. Hopefully I don't give you too many like that, because those are going to be really tough to graph, aren't they? Okay, same idea on the next one. What is A in this case? 1, isn't it? If there's nothing there, it's got to be a 1. P, negative 2. Q, positive 2. Notice how P and Q are the opposites. Okay? So it opens up, so it has a minimum. We know we have 2 solutions, negative 2 and positive 2. Okay, so I'm going to graph those. Now, where is the middle of negative 2 and positive 2? 0, isn't it? So our axis of symmetry is halfway in between, which is 0. So x equals 0. So I know my vertex is going to be 0 something. I also know my domain is always negative infinity to infinity. So simply by graphing this, we figured out most of the problem. Now we got to find our y value. And our y, remember, is we plug in our x, and our x is 0. So that's going to be 2 times negative 2, which is negative 4. So our 1, 2, 3, 4. So our parabola then, our minimum value is negative 4. There's our parabola. So our range is -4 down here up to infinity. Now notice I didn't use the p plus q, did I? Divided by 2 for x. Well, if I do, I get 0. So you can either do it graphically like I did, or you can use this formula here. But once you find x, you got to plug it in to find y. And that's how we always find our vertex. Find x, find y. Now this is kind of funky. Negative x plus 3 quantity squared. Okay, another way of writing this, what does squared mean? Oh, it means write it twice, right? So what are p, well, what's a in this case? -1, right, correct. But p and q are both -3. So you can't have two -3s, so we only have one solution, x equal -3. So if I use the formula, I want to show you something. If I use p plus q divided by 2, you're going to get -6 divided by 2, which is -3. So our axis of symmetry is that point. X equal -3. Makes perfect sense. Well, if that's the 0, now we're going to have to use our brains here a little bit. But this opens down, obviously, because a is -1. So it has a max. The domain -infinity to infinity. If this has one solution, guys, then I'm pretty sure we know that it's going to be -3, 0, and our max value is 0. Well, how can we be sure? Plug it in. X is -3. Plug in -3 there. -3 plus 3 is 0. 0 squared is 0. -0 is 0, so y is 0. So the range would be -infinity up to 0, since it's going to be a max. Now, here's the problem, right? How do we find another point so that we can graph it and we could just mirror the other side? Well, pick something that's really easy. How about something close to this point right here? Something very close. How about -2? So if I put -2 into this problem, okay, so let's see, 3 minus 2 is 1. 1 squared is 1, so that's -1. So the other point would be -2, -1, if we plug -2 in there, and you mirror it, and then we can draw a parabola. Now we have 3 points that we can at least draw it. And you can do this with another point. You can put -1 in there and 0 in there, and you can mirror those to the other side. So once you find one point, you find 2. If you find another point, you now have 4. Okay? All right, now the last one. This is kind of goofy. If you want to make it look like this, ax minus p, x minus q. Well, all we have is x, right? Well, what if we say x minus 0, x plus 6? Now it looks like that p is 0, q -6. A is 1 again. So we have two intercepts, x equals 0, x equal -6. You can graph them. 1, 2, 3, 4, 5, 6. Now, where is halfway in between 0 to -6? Looks like it's right there, which is -3, halfway between 0 and -6. So our axis of symmetry is x equal -3. This thing opens up, so it has a minimum because a is 1. We know our vertex starts with -3. We know our domain is always -infinity to infinity. Now we just have to find the y value. Well, once again, if you recall, x is p plus q divided by 2, but that would be 0 plus negative 6 divided by 2, which is negative 3. So again, you can do it graphically, like I did, or you can use the formula. Now you got to take this negative 3 and plug it into this formula, x times x plus 6. This might be a big one. Not really. 6 minus 3 is 3, so that's negative 9. So negative 3, negative 9. The minimum value is negative 9, which is down here. There's our parabola. So the range is negative 9 to infinity. Once again, you're going to find A, P, and Q. Fill in those numbers where they go. You can either use the formula to find the x, p plus q divided by 2, or you can plot the points, the x-intercepts, the zeros, the solutions, and then work backwards by finding the middle, because some of us like to do things graphically. We see it better. Once you find your x, you've got to plug it in to your equation to find y. Once you found y, you've got everything you need. And this ends our lesson on factored form of quadratic.